Okay, so this is the beginning of a review on the Pythagorean Theorem. And I guess we should start off by talking about right triangles. Okay, so right triangle is a triangle that has a 90-degree angle, and that's what that little box means right there. And the side that's across from that right angle, we call that the hypotenuse, and that's probably not the easiest word to spell. I always think of it as hypotenuse. 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 Okay, and then these other two sides are called the legs. So that's a leg, and this side is a leg over here. Okay, so those are the basic parts of a right triangle, and if you're going to use the Pythagorean theorem, you got to make sure that you have a right triangle, otherwise it doesn't work. So let's look at the actual statement of the Pythagorean theorem. Okay, so here's our right triangle. Again, it has that little box right there, so it tells you it's a right triangle. And the Pythagorean theorem says, well, if we have side, we'll say A, B, C, and those are the lengths of the sides. That's side A, side B, and then the hypotenuse has length C. And it's customary to put the C where the hypotenuse is. I mean, you don't have to, but it's a good way to remember it. Then the Pythagorean theorem says that A squared plus B squared equals C squared. And you have to remember that C must be the hypotenuse, because if it's not the hypotenuse, then it won't work. So C must be the hypotenuse. Hypotenuse, must. Okay. I'm not going to go into the proof of this. I want to just review the Pythagorean theorem. But be sure that when you're setting it up, you put the A, B, and C in the right place. In other words, the hypotenuse has to be by itself on one side of the equation. Okay, so let's look at an example. Here is a right triangle, and we have a side that's a half, a side that's 5/3, and then a mystery side. So we're going to try and find out what x is. Okay, so we're going to set it up, and these are the legs, the 1/2 and the x. So that would be 1/2 squared plus x squared. And then the hypotenuse, 5/3 squared. Okay. And we can square these. 1/2 squared, that's 1 squared over 2 squared, which is 1/4. Plus x squared equals, and then that's 5 squared over 3 squared, or 25 divided by 9. 25 ninths. Okay. So now we got to solve for x. So x squared equals, I can subtract 1/4 over to the other side. And that gives me 25 ninths minus 1/4. Okay, so if I want to solve this, it would be a good idea to subtract these fractions, but in order to do that, I have to give them a common denominator. So x squared equals, and see, common denominator between 9 and 4, how about 36? So 36 and 36. 9 times 4 is 36. 25 times 4, that's 100. 4 times 9 is 36. 1 times 9 is 9. And then 100 minus 9 is 91, and then that'll be 36. And then finally, the last step, if I take a square root of both sides, I actually get plus or minus the square root of 91 over 36, but since our side of a triangle here cannot be negative, I'm going to take the positive square root. So I should write a little plus or minus there, but you know, we want the plus, so I'll just do that one. And then this can be simplified a little bit. Square root of 36 is 6, so that's the square root of 91 over 6. Can't do anything with the square root of 91, but I could type this into a calculator if I wanted to and get something that's about 1.59. Okay, so that's the basic application of the Pythagorean theorem. And I just want to remind you again that the Pythagorean theorem only works for right triangles. Sometimes it can be tempting to use it for other triangles, but then remember, what would the hypotenuse be? There wouldn't be a hypotenuse, so you can't use Pythagorean theorem if you don't have a right triangle.